So now that we have some atmosphere going, let's work a little bit with our level. But first, since I can't see anything in here, let's maybe give it a directional light, just to be able to see some stuff here and there. Okay, and let's create a level for us to, or well, maybe sections for a level. We don't really need an actual level. I'm just going to make this high like that, and let's create some cubes. To block off some sections. For example, we can say, let's say that this is a part of a level, or whatever. Use your imagination to that, obviously. So here's our terrible type of level. And okay, that will be one section. Maybe we can move this from over here, and maybe we can make a way that you have to go from this side or something like that. Again, use your imagination to this. Doesn't really matter at the moment. So what I want to work with is to actually make some sections of our level. So when we're going over here, there's going to be a bit of randomization that is going to spawn either type of enemies or a snapshot of enemies. A snapshot of enemies could be a few enemies that are not randomized the same way these guys are, and we actually don't need them. We only need one. Okay, so will not be randomized as these guys are, but there will be enemies that specific enemies pretty much. We're going to work with prefabs for that. Okay, and I think we might have some other issues to this. Okay, but first, because we forgot to fix our level, let's take all of this, turn them static. Let's parent them underneath a game object, and then let's bake our navigation map again. That's going to take some time. So what I want to go and change now is the behavior for the enemy controllers, because we might want to go, let's ignore that. We might want to have a prefab that is not randomized. Okay, so as you can see here, if is randomized, then you're going to be building, you're going to randomly select anything from your available models, and you're going to do that. I think for the other part, yeah, okay, this will be only happening if it's randomized as well. Okay. Okay. So yeah, that's pretty much it for these guys. So I'm going to take one of them and I'm going to make him a prefab. So let's go into data, create, and make a folder. Let's call it prefabs. Enemy zombies randomized. So I'm going to also tick is randomized and going to make him down here a prefab. So let's delete that, and let's actually delete this as well. Let's fix the framework for this. We're going to go onto the AI and we're going to say AI trigger or AI snapshot. Okay, so the AI snapshot is basically going to be a game object that has a trigger collider, and when the player gets in, it's going to trigger the creation of that. So public game object, or actually let's fix the game object first, because it's going to be somewhat easier. Let's create an empty and let's call this AI snapshot random enemies. Let's add this. Let's place it upon our level, and I'm going to make this have a capsule collider or sphere collider. It's going to be a trigger, and I'm just going to raise the radius to something huge. Okay, this doesn't have to be a sphere collider actually, it can just be a box collider, to be honest. Maybe it makes more sense, depending on your level, it might make more sense to have this under the as a box collider or somewhat. So if this was an actual level, maybe you could just make this box. Okay, so AI snapshot. You know what? Let's do something else. Let's say AI snapshot. Let's call this AI snapshot hook. We'll do it slightly differently. Let's rename this as AI snapshot hook as well. Okay, and this will have just a prefab that is going to be spawning void on trigger enter. Okay, if other equals, actually let's make sure we get a reference that only our player has, and that is the input manager, of course. So input manager np other get component in parent input manager. If input manager not equals null, then that means you're going to instantiate the prefab. So let's do instantiate AI prefab. Parent, we don't really care. What we do care is the position, and that will be your own transform.position, transform.rotation. Okay, you can play a little bit with the rotation as well. And then just going to close this active. If you want to make this so there's multiple cases, or maybe there's a timer that resets it or opens it again, you can feel free to do so. So then this only job will be to take any interaction from the player and instantiate the actual prefab that you're going to be spawning here. So let's make this as AI snapshot, the actual AI snapshot. And from this, we're going to make this into an abstract. Actually, we don't even need to make this into an abstract class. Maybe we don't even need to name this. We can just say AI random zombies. Okay, random zombies, and then AI snapshot. Let's rename this as well. AI random zombies. Okay, and on start, we're going to do some logic. Let's add the namespaces as well. Let's add this. Okay, it's already there. So public integer max zombies, let's say 15. Public integer min zombies 3. Okay, so public game object zombie prefab, or we can load this from the resources, but we can just assign it, so it doesn't matter. Okay, so integer random max random dot range min zombies max zombies plus 1, so we actually get the actual number of zombies we have over here, and then for run dot run, we're going to be instantiating game object zombie prefab. But we want to place it into a correct position. So we're going to find a target position, and that will be your own transform.position, and then I think we can get a random which will be from sphere, actually, is it physics dot, no, random, hold on, so it's random dot inside unit sphere or circle. Okay, the difference with this is that unit circle only has 2 vectors, so we're going to use 2 vectors, and we're going to add on our target position dot x will be, or we're going to add it because it's inside the unit circle. Also, we want to know the radius of this, float radius or spawn radius. Let's say 5, because we're going to have to multiply it with this spawn radius. Okay, so on our x position, we're going to be adding our random x, and on our z position, we're all going to be adding our y position, because this returns a vector 2, which means it's going to return you an x and y random position. It is not going to have anything on the z, so we need to just add it. But the thing is, this doesn't necessarily mean that we're going to be inside the nav mesh. Remember that we are indeed using our nav mesh. So this could spawn anywhere. So we have to make this as to actual position. And to get the actual position, we need to use nav mesh, the nav mesh agent. So that will be nav mesh dot sample position on your target position you have there. And what else do we need there? Yeah, we kind of need to pass a lot of things as well. Nav mesh hit, I think it's useless, so okay, yeah, okay, let's do nav mesh. And I think that's not going to, yeah, this returns a bool. So nav mesh hit then if nav mesh hit sample position out hit the maximum distance to this, let's say 3. Okay, area mask I think is nav mesh dot or nav mesh mask nav mesh dot all areas. Okay, and this, if this returns true, then we're going to create a game object. Otherwise, continue, which is, of course, we don't need it because it's the end of for loop. Okay, so if that's the case, then we will have our hit dot position, and our rotation now, I think it's kind of, well, okay, we could just say find a random rotation as well. So let's do random dot range, or let's do float for rotation, random dot range between 0 and 360. Okay, and we can create a vector 3 for Eulers, vector 3.0, and then r dot y, set that to that, and then this will be quaternion dot Euler angles Eulers, and this needs to be Eulers dot y. So you also have random rotation, but there's the case that this will spawn outside of the player's view, and we kind of have to make sure that the spawn radius is smaller than the radius of your trigger. Otherwise, your player will actually see positions inside Yeah, we'll actually we will see positions inside your level. Let's see. This needs to be Euler. Okay, instantiate that. And the only thing that I'm going to keep track of is how many game objects I've actually created. And that's for pooling reasons. So if a player gets too far away from these objects, we can just delete it. Created objects.add game object. Okay, so this will spawn our objects, our enemies. So let's go and test it. We first need to create the prefab, obviously. Random zombies. Random zombies. And I'm just going to assign the prefab we have for our zombies. And let me find it from here. Okay, I'm going to make this into a prefab. I'm going to delete it, and on my AI snapshot random enemies, I'm going to assign this here. Now, the radius of this collider is 50. The radius for this one is 5. So technically, there shouldn't really be any case that the player will see zombies spawning inside his view. So we can see it right now. So I'm going to move this a little bit to the side so we'll see what's happening here. Notice when I'm going inside the trigger, what's going to happen if everything works, of course. And you can see that indeed there it is, our enemies got spawned. Maybe we did the level a little bit too big for the size we're using. So maybe let's bring this, let's optimize the level a little bit. Obviously, feel free to make this to actually be a level and not just some boxes thrown around. Let's maybe make it like that, and then our AI snapshot random, we can make this to 20 or to 30 from here. Okay, and as I said, we don't really need a sphere collider. This can just be a box collider with, let's set this to 30 and 30, or maybe 40 and 40. We can also raise this to 10. Although this doesn't really matter. So one small issue with this is, I think it's going to start, if we start shooting from here, I think we might be getting the box collision. No, okay. We not the particles, because we're using particles, they just go through trigger collider, so that's really lovely. Let's see, where did they spawn? So it actually didn't spawn anything. That's interesting. It didn't spawn anything because it's high above the ground, that's why. So it didn't sample any positions onto the nav mesh, which means he couldn't spawn anyone because you were high above. Okay, that, as you can see, here we have. The other thing that we can do is basically say that all these zombies are not sedentary. We can just say public float aggro level, and let's say 30, or let's say 60. So we can also get an aggro level for them. Yeah, let's make this an integer actually. Integer aggro random dot range between 0 and 100 plus 1, so 101. And if aggro is lower than your aggro level, Then on that game object, we're going to find the enemy controller. Okay, and I think, let's see how we do this. Handle player detection. Yeah, we can just hardcode the target player, and then we can also find the distance from player. We can just say, you know, this guy is aggressive, so just do that. So going to definition, this is open, and then we want the target player, which is also public as well. So, however, we do need a reference to the player now, which I guess we could just take it from the input manager. But a better way to do this will be from our managers. Oh, we do not have the managers yet, so let's fix them now. I'm going to add a class, which I'm going to call settings. And we don't need any of this, we don't need this, and we do not need the abstract. Actually, this needs to be static, not abstract. Static class. Okay, so then I'm going to have a static input manager. The input manager is, of course, needs to be initialized. So on start, we're going to go settings dot input manager equals this. So on our AI random zombies, I could just do controller dot has or target player settings dot input manager dot, can we get the controller, or because I know it's on the same game object, I can assign this, and I can say controller dot is aggressive equals true. Okay, you can also add a game object that maybe the zombie is already dead, so the players don't actually know if it's alive or not. Of course, feel free to see that. Okay, so if it is, you can see, yeah, we have a few issues, but I think those issues coming because we do not play the animation. So let's find the enemy controller and let's see where we are setting the, yeah. So we basically need this. So we can say public void set aggressive on the target transform. So target player equals target. Okay. So basically just this. So we're going to be calling this and they will start moving. Back to the AI random. Instead of doing this, I can just say controller set aggressive settings input manager transform. Or better yet, we could just say public static player controller. Let's see, how do we have this name actually? We just have it controller. Okay, so I'm going to say controller. And actually I'm going to just name it controller. Or local controller, that will be better to be honest. Local controller. Okay, so here local controller.transform, and then on your input manager, instead of setting the input manager, which doesn't exist anymore, we're simply going to assign the controller. So you do not need any reference to that one. So let's hit play. let's go and trigger that. Let's see where is the issue. Oh, the issue is that there's no animator yet, so you can't set aggressive, which means we might have to do the start on command. So I'm going to say is init, and if not is init, or if is init, return. And I'm going to take all of this and add it inside a void init method. I'm going to say if is init is going to be true. Okay, so this will be false. It's going to be initting, but that means I can check on send aggressive. If not is init, close that and hit play. Okay, and there we go. Out of the not many, one of these guys was initially aggro by itself. Okay, and that means we can keep firing and firing. Awesome. So that's the first snapshot for this. So let's finish this part. On the next one, we're going to see the other types of snapshots we can have. I'm just going to show you only two, or okay, we'll see how many we'll do. There's a lot of things that we can do, and one can be connected with the other. So if one returns a result of this, this one can return a different result, and vice versa. So anyway, that's it for this part. So I'll see you on the next one. As always, you know what to do. Like, subscribe, and if you'd like to see more stuff like this, more videos, more series, more of everything, of course, consider supporting my Patreon so we can keep making all of these. I'll see you next time.